In today's video, I wanted to go over the log rules, three main log rules. We will be reviewing the power rule, the product rule, and the quotient rule. So as a real quick review, if we go over our just basic log rules, I always tell myself that the log equals the exponent. So if we were asked to solve something like this and we needed to know what x is here, I always say the log equals the exponent. So we're going to change this to exponential form. If the log equals the exponent, that means x is the exponent. So 5 to the x has to equal 25. I call this the answer position. This is my answer or result. 5 to the what equals 25. Well, I know that that has to be squared. 5 squared equals 25. So x equals 2 in this case. So that's just a quick review of the positions. One more, if we have x now in the base, log to the base x of 32 equals, let's say 5. So if I change this to exponential form, I'm saying my base is x, my exponent is 5, and my answer is 32. This is the answer position. So I have to think about what raised to the 5th equals 32. And I know it's got to be a pretty small number, right? I might not know this one by heart, but I know that it can't even be 3, right? 3 is too great. So I'm going to think about 2. And in fact, 2 to the 5th equals 32. And I can double check my math there, right? I know that 2 squared is 4. 2 squared is 4. 4 times 4 is 16, and I need one more 2 would be 32. So that would be 2 squared, and this is 2 to the 1. So that would be, if we remember our power rules, if I have the same base, I add the exponents. So that would be 2 plus 2 plus 1. That would be 2 to the 5th equals 32. So sometimes going over those real quick exponent rules are helpful just to remember all of these. Okay, so in that case, when x is in that position, the base, that would be 2. So in our case, x equals 2. So that's just a quick review of kind of the positions of the logs. So now let's go over some more of these rules. So the first one is going to be the power rule. And the power rule just means that if I have a base and an answer that is squared or has an exponent, that means I can bring this guy in the front. So I would bring him in the front, and if these two numbers are the same, that just means essentially I could think about what does this equal? The log equals the exponent. That is 7 raised to the 1 has to equal 7. So this whole thing just becomes 1. So essentially evaluated, this whole answer would just be 3 because we brought the 3 to the front. So the power rule is if something is in that answer position that has an exponent, I can just bring it to the front. So if we needed to know what x is, let's see, if this were 4, I needed to know what x is. So again, I can bring it to the front, and this would be 2 log base 2 of x. So this would be the same. These would be equal. I just bring that exponent to the front. These are equal to each other here. And now this equals 4. Now what can be done, which is nice, is now essentially I could just divide both sides by 2 here if I needed to solve for x. So if I divide both sides by 2, log base 2 of x now just equals 2. And then again, I can rearrange to exponential form. The log equals the exponent. This means 2 squared has to equal x. This is my answer position here. 2 squared equals x. Well, in that case, 4. X just equals 4. So we could have rewritten this log base 2 of 4 squared has to equal 4. And if we know 4 squared, we know that's 16. Log base 2 of 16 has to equal 4. And again, log equals the exponent, so that means 2 to the 4th equals 16. And that is true. 2 to the 4th is 16. So that was correct. That was just a way of checking our answer. But in that case, x is 4. So that just proves, right, the power rule. If I have an exponent in this position, meaning my answer raised to an exponent, I can bring it in the front. And that comes in handy, especially when I'm trying to solve for stuff, because then I can divide it out if I need to, or add it with other stuff if I have coefficients. So that is the power rule. So let's move on to the product rule. The product rule means that if I have two things, let's just say this is common log or log base 10 of x squared times z. We're just going to use two different variables here, two different animals, nothing too scary. All that means is I can expand, this is called expanding, but when two things are being multiplied, I add them. So I'm going to keep my same base, and this would be x squared plus log base 10, same base, of z. So these two things were being multiplied. Now they are being added. So sometimes you just have to kind of take note of the two things that are being multiplied. Sometimes it gets a little bit tricky as to where you put the logs. But it's called expanding when we go this way because I'm separating into two different logs. So you can see I have now two separate logs. That is not the same as log base 10 of x squared plus z, right? That would not be the same thing. You can see that. So it's not like we're just like distributing, essentially. That is not the case. Sometimes that gets confusing. So that is not what we're doing here. We want to make sure we expand by getting two separate logs when we add. If we're going the other way, we call it condense. So if I were given this, I could say, oh, I'm adding and I have the same base. So then I would multiply the two things that are in that answer position. So let's try another one. If we had log base 10, let's say, of 3x, we could write that as log base 10 of 3 plus log base 10 of x. So in this case, this isn't anything nice. Log base 10 of 3, that's not really a nice answer, but let's say it were, let's say it's 100, right? That would be a nice, easy answer. Log base 10 of 100x, well then I could separate that into log base 10 of 100. I know 10 to the what? The log equals the exponent. 10 squared equals 100. So this answer, this whole part becomes 2. So if that were helpful, right, in this case, I don't know that that's any better, but we could rewrite that as 2 plus log base 10. I don't always have to write it, log base 10 of x. That's my common log. If there's no base listed, it is 10. So that would be another way to expand that. And sometimes it comes in handy when you're trying to solve. So that would be expanding. If they're being multiplied here, those are the parts. I have two different logs, and those are the parts here. So that is the product rule. When I'm multiplying, I can expand and add. So now let's talk about the quotient rule. The quotient rule is what you would guess, similar to our exponent rules. When I have two things that are being divided, quotient goes with division. If I had x squared over y squared, I could say, now that expands to two things subtracting. So I have my top minus, and I have two logs. So I'm separating, expanding into two logs. Log of y squared, that would be my bottom. So when we're dividing, we're subtracting. When we're multiplying, we're adding. Very similar to exponent rules. So here, in this case, sometimes this might come in handy where you would want to, maybe you could evaluate this and not this or something like that. So sometimes that would come in handy. And again, we could use our power rule again here. Both of these have exponents in that answer position. So we could rewrite those as 2 log x minus 2 log y. And again, these are just being multiplied. So if it helps us solve, we could really divide both sides by 2. Let's say we were given that this whole thing equals 4. Then we could go ahead and divide both sides by 2 in order to solve. In this case, we have 2 different variables, so that doesn't really help us here. But it may help when depending whatever problem you're given. So that would be expanding and the quotient rule. When I'm dividing 2 things, I can expand and subtract. So these are the 2 things that I'm dividing. So sometimes you just have to be really careful about where, what's my whole thing on top and the whole thing on bottom. So if we had like an entire situation where it was like x plus 3, that's my whole top, divided by, let's say, a whole bottom, x squared, let's say minus 4, that would be the whole bottom. This is where then I could expand, and I want to keep 2 different logs. So that would be x plus 3. So sometimes I give myself parentheses to kind of make it clear. My whole top minus the whole bottom, x squared minus 4. And this one, we could even expand some more. So I know how to factor this. If we recognize this as a difference of 2 squares, we could expand that one even more. So I'm going to give ourselves some room up here, and let's try expanding that some more. So x squared minus 4, I know that factors into 2 factors. It's a difference of 2 squares, so it has to be 2 different signs. And my perfect little square here is 2. I can always FOIL to check. First, x squared, outer is minus 2x, inner is positive 2x. That's what cancels out, so I don't have a middle term here. And my last term is minus 4. So just a quick review on that one. So that one factors to x plus 2, x minus 2. So again, if we just rewrote this portion down here, I have log of x plus 3 minus, and this is where we want to be careful because I'm going to subtract whatever this reduces to. So if this reduces to something else, I'm still subtracting that whole chunk. So this I could rewrite as the log of x plus 2, x minus 2. And what did we just learn? When things are being multiplied, that's product rule. So when I'm multiplying, I add. So again, if we subtract the whole thing, in here I could write 2 separate logs, log of x plus 2 plus log of x minus 2. So that would be expanding just that little portion, and we're subtracting that whole thing, so we would want to distribute that negative. So we still have our log of x plus 3. I'm distributing this negative. So all that means is I can take away my parentheses and make that guy negative. So this really is the fully expanded version of our original here. So these 2 are equivalent. My top minus my bottom, and my bottom we could expand also because it was 2 things being multiplied. So then we add, and because I'm subtracting that whole thing, I have to make sure to distribute that negative. So that would be a larger example of the quotient rule. When I divide, I subtract. So again, give yourself parentheses so that you know what your whole top is and your whole bottom. Okay, so let's practice this going the other way. We would call this condense, meaning if we were given an already expanded example, let's try this one, log z. Let's say we just have 2 variables. So we are asked to condense. Well, I see 2 things being subtracted. So immediately I think, okay, again, we can give ourselves parentheses. What am I taking the log of? And when I'm subtracting, I know I'm dividing. And it may be easier to see, I have this 3 in front. That's my power rule. So I could put it up there as my exponent. So I could rewrite this as log of x minus log of z cubed. Now I just have two whole things being subtracted. So condense, I'm going to condense them down to 1 log. So I have log, I'm subtracting, so I know I'm dividing, quotient rule. So I'm going to do my top divided by the bottom, or the first divided by the second, and it's the whole piece. So in that case, it would be x over z cubed. So it makes more sense because if I had just written this, right, if the 3 is there and I try to condense, I kind of don't know what to do with the 3. I need the logs really by itself. So I wanted to move. They have to be the same base also. These aren't written here, but this would be a base 10. So if I just try to initially do it without moving the 3 to that power rule position, it's a little harder to think about because they don't look the same. If this one also had a 3, I could have divided both sides by 3 if I had been set up that way to know what it equaled, or if that made sense to divide it out first. But in this case, I can just use power rule, and then that becomes the whole thing that I'm subtracting. So that is my bottom part of the division or quotient rule. So that would be condensing. If I have two things, and now I'm condensing down to 1 log. So condensing, we're getting back down to 1 log. Expanding, we have 2 separate logs. So let's try just one more, where a little bit more complicated. If I were given this, and this is often how it would be, where you would be given what it equals, and you would be asked to solve for x. So let's see what happens here. This would be log 3x minus 4. So again, we kind of take a bigger picture and we think, okay, what are my rules that I can apply? When we have two different things on either side, right? Clearly, right off the bat, this is not the same as this. This is not just expanding or condensing. So that means I want to do whatever I can to both sides to see what makes sense. So starting off on the left, I immediately see my power rule. So that might make sense to go ahead and move that guy to the power position. So that is the same as log base 10. All of these are common logs, so I'm not going to write those. Log of x squared. Those two are the same. So my left side I've reduced or done change, so might be helpful. Now over here, if I can get these combined, so if I could condense these into 1 log, again, if I have log to the blah, or log base 10 of blah equals log base 10 of blah, well, my two blahs must have to equal each other, right? Log of something equals log of something, those two somethings have to equal each other. So sometimes that's a helpful method to solve for a variable. So if I can get this down to 1 log, then I just have log of something equals log of something. Well, then I could set those two logs equal to each other. So I'm adding, so to condense, I would need to multiply. That would be product rule. So if I multiply, these are my two somethings that I'm taking the log of. So that would be 2 times 3x minus 4. So I want to keep my parentheses. I'd have to do double parentheses there. So now if I say log of, if I distribute this through, that would be log of 6x minus 8. And over here on the left, we said that was log of x squared. So again, if I have log of blah equals log of blah, well, my two blahs must have to equal each other. So I could just set x squared equals 6x minus 8. Immediately, this looks like a quadratic, and I want to get that equal to 0 in order to factor. So I'm going to move these two things to the left because I really don't want a negative in the first term. So if I have x squared and I move those other guys to the left, minus 6x plus 8 now equals 0. And if I think about factoring, I know I have an x and an x. I need two things that multiply to get 8 and add up to 6. So immediately I'm thinking 4 and 2. I need 6 to be negative. That would be two negatives because I need it to be -4 more negative minus 2. So if I set those equal to 0, x would equal 4 and x equals 2. So if we were asked to solve for x, these would be my two answers for x. X equals 4 and x equals 2. Oftentimes when x is in this position, the answer position, if we think about this, if we have, let's say it's 2, and any number over here, even if it's 0 or negative, my answer, let's say it's -100. If I rewrite this in exponent form, that means 2 to the -100. We know that equals 1 over 2 to the 100th. Still positive. So the whole point being in this answer position, this is log base 10, remember, this is our answer position. When x or a variable is in that answer position, it always has to be positive. It can't be 0 and it can't be positive. Or I'm sorry, it can't be 0 and it can't be negative. It always has to be a positive integer. So because, again, if this is 0, that just means 2 to the 0 equals 1. This would never be 0 and never be negative. So any number raised to an exponent is never negative and never 0. Never 0 and never negative. So if we ever got an answer here where x was negative when we factored or something like that, let's say we ended up with a -4, we would know, going back to our original equation, this position can never be negative or 0. So if we had an answer that was negative, we would call that extraneous. So that might be something that comes up in your problems or homework where you would be asked to double check to make sure. Check for extraneous just means in that position, if x is in that answer position only, I care because it can never be 0 or negative. So that would just be an additional thing to look out for. That is the log rules, reviewing the power rule, the product rule, and the quotient rule. Feel free to leave any comments below with your questions, and I'd be happy to answer them.